Hello and welcome to my Cornerstone colleagues. First of all, thank you for choosing to view the master's project that I'm actively implementing in my high school chemistry class. I'm very excited to share the details and preliminary successes that have been realized. This project involves the combining of two data-driven strategies of classroom content delivery. As the picture suggests, I believe it is helping students see chemistry in more effective ways. The title of my project was Combining Modeling Instruction and a Flipped Classroom. It involves the conversion of a traditional teacher-centric classroom, shown here on the left, to a more blended learning experience where students enjoy the challenges of hands-on, inquiry-based discovery with the support of personal, teacher-delivered content in an online environment. First, to prepare you, let me share how the presentation is organized. First, I felt that it was important for you to know a little background about each of the strategies to be blended and the literature that supports each of them. Next, I will show you how I plan to blend them together. During this section, I will share the early successes that have been realized and also the challenges that are being faced. I will also talk about how I think this project and its outcome may affect our school and our district. I will then conclude with how this style of teaching fits in with a biblical worldview approach. As I said, I teach high school chemistry at Sullivan North High School, which was founded in 1981. In the year since its inception, North has experienced drastic socioeconomic change. While initially a high school of approximately 1,200 students from largely stable middle-class families, the school is now fighting for survival with an enrollment of approximately 582, and that comes from a very transient community. The school suffers from a poor academic culture and also has a defeatist attitude. A new administration that began last year, however, has breathed life back into the beleaguered faculty and to many of the students. It is into this environment I have introduced the modeling chemistry curriculum. Developed by Arizona State University in the 1990s, the concept of this research-based curriculum is to help students investigate the visible world of science and to discover the invisible or micro world in much the same way as the original atomic theory scientists did. It is very hands-on and steeped in inquiry. The second strategy is the flipped classroom, which is certainly a 21st century curriculum strategy. In this delivery, students engage in content videos or other activities outside of class to accomplish pre-learning in order to provide class time for application of the concepts learned. While each of these classroom delivery approaches have proven successes individually, it was my intention to demonstrate that the synergistic benefits of using both of them would yield improved student engagement in learning. While literature findings will be shown in the next slide, I believe that it merits pointing out what Berliner stated in 2004 work on reaching unmotivated students. His work said that regardless of all the causal factors that play into our current educational challenges, one fact remains, that being that eagerness to learn is an inherent capacity in all students. The literature review then focused on finding the strengths and weaknesses of each strategy with respect to student apathy, student engagement, and impact on critical thinking skills. Research on the modeling approach includes the following. From the U.S. Department of Education, modeling was recognized as an exemplary program out of 27 evaluated. Sachetal's 2012 research on the desire of students to be decision makers in their learning is directly relevant to the guided inquiry activities incorporated within the modeling curriculum. And finally, Jackson's 2008 report sings the praises of the modeling curriculum's ability to foster academic engagement, critical thinking, and collaboration skills. Similarly, research on flipped classroom abounds with respect to increased student engagement. With the increased availability of fast internet connections reported in 2011, a flipped classroom is within our grasp now more than ever. And certainly, when combined with the saturation of smartphone use among secondary students, we see the increases in engagement reported by Williams in 2012. However, ensuring that they are engaged on the proper things is a critical battle we all face. One of the significant opportunities that lies with the flipped classroom is the ability to differentiate instruction on an individual basis to provide the personalized learning experience reported by Dembski. In fairness, we should also discuss critical views of each strategy. First, for the modeling curriculum, inquiry learning takes time, so much that it often upsets the normal and familiar pacing guide. This becomes a large source of stress for high-stakes testing crowd. It also requires strong facilitation skills by the teacher. Each class and student brings a totally new conversation with different preconceptions that must be worked through. It's also viewed as content weak by some, but much of this criticism is related to the items above. If a teacher is unable to facilitate the academic conversation to be time efficient with learning, then there will be inevitably a reduction in content coverage. On the flipped classroom, there are also critics. They say it requires a significant investment of time up front by the teacher to procure, upload, and troubleshoot the digital delivery. Organization is paramount, not just at setup, but throughout the delivery of the course to ensure that students are participating, submitting assignments, and demonstrating digital responsibility. One of the chief critics of flipping learning is the idea that students will just fend for themselves without teacher involvement. Two final literature references speak directly to the need for teacher involvement in a blended classroom. Chandra and Finch speak directly to the role of the teacher in a flipped classroom. Relationships must still be fostered, and individual academic support is even more necessary since technology learning must also occur simultaneously with course content. Frost reports that it is this classroom teacher that is uniquely qualified to strategize the best approach, and that is certainly what I've intended to do. The idea behind my project was that these two proven approaches were particularly suited to complement one another. For example, the real need of teacher interaction for the flipped classroom would be met with the guided inquiry activities and relational teaching accomplished during the model activities in the classroom. If my face-to-face meetings, utilizing this inquiry-based learning activity, left students with unanswered questions at the end of class, they will have the opportunity of an online environment and its rich technology capabilities to allow for practical use and further clarification of the day's face-to-face activities. In so doing, I hope to provide more at-bat opportunities for my students to move short-term knowledge to long-term transferable understanding. To accomplish this type of blended classroom, I did a thorough investigation and review of the modeling curriculum in relation to our state's chemistry SPIs and the associated pacing guide recommendations. Knowing that it would be impossible to follow the curriculum to the letter in an 18-week course, I identified the foundational learning objectives that would best be discovered by hands-on inquiry, and then looked to supplement that understanding with web-based activities that would help cover the other particulars of our state's SPIs in the time allotted. Then, following the logical progression of the 10 units within the modeling curriculum, I created a parallel online classroom using Schoology as the learning management system. One necessary component of the online class was a preliminary unit where training and account sign-ups took place for the various tech tools that we would be using. This course introductory unit lends itself very well to the first week of class, since delivery of classroom policies and procedures, as well as a number of student questionnaires and pre-assessments to help in determining the effectiveness of this program, could be incorporated as part of the introduction to various technologies and the upload-download training needs that would be necessary. Once we have the students all signed up and equipped with the various login credentials, it is time to begin the chemistry instruction. The modeling curriculum sets forth the unit-by-unit sequenced hands-on activities, and the Schoology class provides online complementary practice and assessment activities that supplement learning in exciting ways that were never part of the classroom just a few years ago. For example, Unit 3, which you're looking at now, introduces discovery activities in class using vernier probeware to investigate gas laws and an early understanding of chemical energy. Students demonstrate their understanding and academic literacy with in-class whiteboarding activities, and then can explore real-world applications in an online learning laboratory where they can build and test various pressure chambers and evaluate the impact of changing key parameters. Likewise, in Unit 7, students work collaboratively in a face-to-face classroom, setting about to draw compounds using known elements after deciphering the mathematical code. Then they would use 3D element sets in class to build the compound they have drawn, and in so doing are often surprised that the shape is completely different in 3D than on paper. Then, as a follow-up assessment in the online classroom, the activity that you're viewing on the right of the screen within Schoology allows the students to build a wider range of chemical compounds, and they can begin to understand the names of the various shapes and the associated bond angles. I only wish this technology had been around when I was a student to explore the practical use of what I was learning. My latent desire, however, is their reality. Students are engaged more than ever before, and the sidebar conversations within my classroom are much more likely to be academic these days. Debates and disagreements about molecular shape and collision theory are commonplace once the students begin to assimilate the various modes of learning, and it has made for a very rich learning environment. As I began to implement bits and pieces of this approach over the course of the last year, I did not realize the impact it was having. In order to evaluate the effectiveness of this blended curriculum, students take pre- and post-course tests that are identical to the pre- and post-tests used in traditional classrooms in other schools in our district. Comparisons of preliminary data are very promising. Additionally, Tennessee requires an EOC exam at the end of the course. To measure student growth, a preliminary expected achievement level is determined prior to the students taking the test. After only 1 year and only partial implementation of this dual approach, the student growth numbers for my blended students were nearly 30 points higher than our district growth scores. Now, the challenges have also been faced. Chief among these challenges has been the technology infrastructure of our school. Fortunately, major strides were made over the 2014 summer to significantly improve our Wi-Fi and internet capability. Another hurdle has been the availability of technology for all students in our Title I school. With each hurdle, however, lies an opportunity, and the school, along with an incredibly generous local organization, are looking to provide funds necessary to implement a one-to-one rollout in 2015. Another significant issue among the students is the level of technology literacy that actually exists. Knowing how to text and Facebook does not equate to academic digital literacy, and we have also spent a significant amount of time training on digital citizenship. So what's next? For my classes, I hope to extend this approach based on its promising results beyond introductory chemistry to my AP chemistry classes. The new AP chemistry curriculum changes coincide with this goal and are in direct agreement with an emphasis on guided inquiry. Within our science department, my colleagues are observing the gains being made among the chemistry students and are looking at implementing the modeling curricula that are available for physical science, physics, and biology. In addition to the previously mentioned goal of one-to-one in 2015, our school is actively training staff and faculty on a variety of Web 2.0 tools, and we have been chosen as a satellite school for trying and implementing new technology in our district. For me personally, I was asked by my administrators to accept a technology coordinator role this year on top of my classroom teaching expectations. As I finish up my Master's of Ed Tech here at Cornerstone, this was an exciting and flattering request, and I look forward to working with other members of our staff to continue our incorporation of technology within our existing class. And who knows really what God has in store. As the focus area of this research project continues to unfold, my biblical worldview will provide a framework of godly wisdom to aid the careful selection of activities for model discovery and deployment. Additionally, it will provide the protection necessary as relationships among my students are established in both face-to-face and online settings. The research will be conducted with students who have different worldviews than my own. However, the importance of valuing academic pursuits needs to be established in order to defend what we believe. Thank you so much for your time in viewing my master's project presentation. May God bless each of you, your families, and your students.